Have you ever wondered how a simple plant substance could become a life-saving medicine? Today we dive into the fascinating world of cardioactive glycosides, an intriguing discovery that has revolutionized the way we treat heart conditions. Our journey begins centuries ago when the effectiveness of a humble plant, Digitalis purpurea or the common foxglove, was recognized. Known for its beautiful bell-shaped purple flowers, this plant was used in folk medicine for a variety of ailments. But it was its role in treating heart conditions that truly set it apart. You see, hidden within the foxglove's leaves was a substance that could stimulate the heart. This miraculous compound, with its potent properties, was destined to change the course of medical history, but it wasn't until the late 18th century that its true potential was unlocked. Enter William Withering, an English physician and botanist. Withering was intrigued by the foxglove's medicinal properties and began investigating. Through careful experimentation and observation, he was able to isolate the active component from the plant's leaves. This active component we now know is a cardioactive glycoside, specifically digoxin. This discovery was nothing short of revolutionary. Withering's work laid the foundation for the use of cardioactive glycosides in medicine. He found that when used correctly, digoxin could significantly enhance the heart's ability to pump blood. It was a game changer, offering hope for those suffering from heart conditions. But Withering's discovery was just the beginning. The world of cardioactive glycosides was vast and largely unexplored. As the years passed, more substances with similar properties were discovered, each with its own unique potential. So the journey of cardioactive glycosides began, from a humble plant to a potent medical tool. It's a tale of curiosity and relentless pursuit of knowledge, reminding us that sometimes the most powerful medicines can be found in the simplest of places. But what exactly are cardioactive glycosides and how do they work? These compounds are fascinating entities. They are a type of organic molecule, a class of steroids to be precise, that have a sugar component attached to them, hence the term glycosides. The steroid portion is the cardioactive part, which is responsible for their impact on the heart. The sugar part helps in making these compounds soluble in water, thus aiding their absorption and distribution in the body. Now let's dive a little deeper. The steroid part of the molecule interacts with a very specific protein in the heart cells, the sodium-potassium ATP-PACE pump. This pump is responsible for maintaining the balance of sodium and potassium ions inside and outside the heart cells, which is vital for normal heart function. So how do cardioactive glycosides play a role here? Well, they bind to the sodium-potassium ATP-PACE pump and inhibit its function. This causes an increase in the level of sodium ions inside the cells, which then leads to an influx of calcium ions. The increased calcium concentration causes the heart muscle cells to contract more strongly and effectively. But here's the catch. While these compounds can be beneficial in certain heart conditions like congestive heart failure and arrhythmias, they have a narrow therapeutic index. This means the difference between a beneficial dose and a toxic one is very small, making the safe use of these compounds a bit of a balancing act. We also need to understand that the effects of cardioactive glycosides are not immediate. They take time to build up in the body and exert their effects. But once they kick in, they can have a profound impact on heart function, improving the efficiency of the heart and making each heartbeat count. In essence, cardioactive glycosides are nature's own heart stimulants. They were discovered centuries ago, and yet their potent and complex effects on the heart continue to intrigue and challenge scientists even today. Digitalis may be the poster child, but it's not the only plant source of cardioactive glycosides. Allow me to introduce you to the lesser-known cousins, Squill and Strophanthus. While they may not enjoy the same degree of fame as Digitalis, their contributions to the world of medicine are equally noteworthy. Let's begin with Squill. This plant, hailing from the Mediterranean region, has a long history of medicinal use. Ancient Egyptians, Greeks, and Romans used squill for its diuretic and cardiac effects. Squill contains several cardioactive glycosides, including silyrin A, which has a potent effect on the heart. Today, squill is still used in some parts of the world for the treatment of congestive heart failure, showing that old remedies can still hold their own in modern times. Moving on, we come to Strophanthus. This tropical vine native to Africa and Asia is known for its striking flowers and its potent seeds. These seeds contain a cocktail of cardioactive glycosides, including strophanthine and uabane. Historically, strophanthus seeds were used by African hunters to poison their arrows. But don't let that scare you away. In the right doses, these same compounds have been used to treat heart conditions. Strophanthus is less commonly used today, but remains a fascinating example of nature's dual capacity for harm and healing. So while Digitalis might be the star of the show when it comes to cardioactive glycosides, it's clear that it doesn't steal the whole spotlight. Squill and Strophanthus, despite being lesser known, have made their mark on the world of medicine. Each plant source of these potent compounds has its unique characteristics and uses. They remind us of the incredible chemical diversity found in nature and the potential it holds for the discovery of new medicines. Just like a family, each member of the cardioactive glycosides clan has its unique characteristics and uses. Now let's bring the spotlight to the contemporary uses of cardioactive glycosides. These compounds, derived from plants like Digitalis, Squill, and Strophanthus, have found their place in the annals of modern medicine, particularly in the treatment of heart conditions. The heart, as we know it, is a tireless workhorse, pumping blood throughout our bodies, but sometimes this relentless organ needs a helping hand. Enter cardioactive glycosides. These naturally occurring compounds have the unique ability to increase the force of the heart's contractions, allowing it to pump blood more effectively. This makes them an invaluable tool in the management of heart failure, a condition where the heart simply can't pump enough blood to meet the body's needs. But the magic of these glycosides doesn't stop there. They also have the ability to control the heart's rhythm, making them an essential part of treatment protocols for atrial fibrillation, a condition characterized by a rapid, irregular heartbeat. By slowing down the heart rate, these compounds can help restore a regular rhythm, offering relief to millions of people worldwide. Beyond these well-established uses, ongoing research is unveiling new potential applications for cardioactive glycosides. Scientists are exploring their role in treating other heart conditions, and even their potential in combating certain types of cancer. It's an exciting time, with every new study offering a fresh perspective on these age-old compounds. As we delve deeper into the world of cardioactive glycosides, we are continually reminded of the complex interplay between nature and medicine. These compounds, once extracted from humble plants, are now synthesized and refined in laboratories across the globe, ready to lend a helping hand to the human heart. So next time you see a foxglove flower swaying in the wind, remember that within its petals lies a compound with the power to give life a fighting chance. From the heart of nature to the heart of man, the journey of cardioactive glycosides is a testament to the power of nature and human ingenuity. Indeed, the journey of cardioactive glycosides is a testament to the power of nature and human ingenuity. As we come to the end of this fascinating journey, let's summarize what we've learned about cardioactive glycosides. We began with the intriguing discovery of these potent compounds, tracing their origins back to nature's apothecary. We delved into the rich history of therapeutic glycosides and how the wisdom of ancient healers has shaped our understanding of these substances. We then navigated the complex world of cardioactive glycosides, exploring their unique structure and properties. We learned that these compounds, which include Digitalis, Squill, and Strophanthus, are known for their ability to influence the heart's rhythm. They work by inhibiting the sodium-potassium pump, leading to an increase in intracellular calcium and a rise in cardiac contractility. Next, we turned our attention to the lesser-known cousins in the glycoside family. We discovered that beyond the well-known Digitalis, there are a plethora of other glycosides, each with their unique benefits and potential applications. In the modern era, we've seen how cardioactive glycosides have carved out a niche in medicine. They're used to treat a range of heart conditions from atrial fibrillation to heart failure. These compounds have proved invaluable in the fight against heart disease, improving the quality of life for millions of people worldwide. Looking ahead, the future of cardioactive glycosides is bright. Researchers are continually uncovering new potential applications for these compounds. There's ongoing research into their potential use in cancer treatment, and early results are promising. Furthermore, as our knowledge of these compounds grows, so does our ability to manipulate their properties and tailor them to specific therapeutic needs. So we've journeyed from the ancient world to the cutting edge of modern medicine, exploring the intriguing world of cardioactive glycosides. It's a journey that's far from over, as these potent compounds continue to reveal their secrets and offer new possibilities for healing. And there you have it, the fascinating world of cardioactive glycosides. Subscribe for more because you won't find me later.